So Deepika B was asking that how can we uh, determine the best fitted line most probably. This was the question. So the answer is that you have previously seen, I would like to show you the slide that this best fitted line, I previously yesterday I told
Hello.
the yesterday I told you, yesterday I gave you this example of this is the x and this is the y. This example of simple linear regression I have told you. Okay. So I have also show you that these are the data points. Okay. And you try to find out the best fitted line. Okay. So actually, what is the best fitted line? Best fitted line means you want to find out a line which will minimize your variance in data. The variance that you can see in the best fitted line, that is actually unavoidable variances. The common variance you can segregate using the method of regression analysis. Okay. So it will only reflect you the unavoidable variance or the uncommon variances like error variances or the unique variance. Okay. So maximum likelihood estimation, it is also another way of reducing this kind of the variation. Okay. So or you can say in order to find out the best fitted line. Okay. So what you can do, so in logistic regression, the name is actually derived from logic transformation. The log odds makes things symmetrical, easier to interpret and easier for fancy statistics. Okay. See, logistic regression is a little bit complex. Basically, logistic regression, you have seen that in normal regression, the response variable y, it is actually that nature is it is continuous data. It is not discrete data. But if you have discrete data in your response variable, yes or no based, then you will use logistic regression. Okay. Now there are two different types of logistic regression. Okay, there are two different types of logistic regression. One is when you have your dependent variable and independent variable, both are discrete in nature, and when your dependent variable is obviously discrete in nature, but your independent variables are continuous in nature. Okay. So in that case, we use logistic regression. Okay. So I have given you some links. If you are very much interested to find out that how logistic regression it is actually performed. Okay. If you use software, you can very easily you can find out what will be the equation. Okay. For example, suppose if you just have a look at this example. Okay. Suppose the our studies, this is actually the independent variable x, and your y result is 0 or 1. That means pass or fail, that is given. Okay. So, and in the logistic regression, it is based on actually the sigmoid function. This kind of S function you will see. This is known as sigmoid function. So if you put these kinds of data and if you apply the logistic regression, so automatically you will be getting this kind of the equation. Okay, so that that will be generated by the software automatically. Okay, and from that you can also calculate for a particular value what will be the probability. Okay, so that you can also calculate. Just you need to suppose how to calculate the probability of pass for the student who studied 33 hours. Okay, so what you will do, suppose for example the this expression, it is given, it will be given by your software. So if this kind of expression is given, okay, so you will put these values here, so you will be getting the values of Z, and then if you put these values in here, it will be actually Z, not X. Then you can find out the probability very easily. Okay, 0.88, you put this value and you will be getting the value of probability. Okay, so what I'm trying to say that this equation that you can find out easily, but usually in logistic regression it is the chance, it is dichotomously considered, that whether suppose this student will pass or fail, though you can measure suppose the pass of the pass chance of probability of this particular student, you have got 53%. So you will be concluding that this student can pass. If you find that the scope or the probability that the student will pass, it is 48%, so you will say that the student will fail. That is the probability. So in this way we consider. So it will be automatically determined by the software if you give or if you plot those data. Okay, but if you want to know about the mechanism, then the two video links I have given to you, you can find out this mechanism, you can go through it. Okay, so the basic things I'm just telling you, that logistic regression predicts whether something is true or false instead of predicting something continuous like size. This I have already stated. The second thing is also, instead of fitting a line to the data, logistic regression fits an S-shaped logistic regression. The S-shaped curve, which is known as sigmoid function, this you will find in logistic regression. Okay. The curve goes from 0 to 1. Suppose along x-axis you are representing the weights of different mice. Okay. And along y-axis you are representing the probability that the particular mouse will be obese or not obese. Obese means overweighted related disease. Okay, obese or not obese. You can clearly see from the graph that the mice that are heavily weight, there is a probability that they will be obese, and the mice that are have less weight, they have less tendency to be obese. Okay, suppose if you consider this point, that means you will get, if you if you draw a vertical line, it will cut here, so it will have a 50% chance, you can see, that the mouse will be obese. Okay, the curve tells you the probability that a mouse is obese based on its weight. Then logistic regression doesn't have the same concept of a residual, so it cannot use the least squares and it cannot calculate R square. So as I have told earlier, that the logistic, since you cannot use directly the concepts of the residual, and you cannot use also the least square method. Least square method is not there. Okay, so that's why you you use here the maximum likelihood estimation. Okay, you use here something called maximum likelihood estimation. Okay, and suppose this is the thing what I told you earlier. Okay, suppose the obesity, this is the variable y, it is predicted by weight, genotype, age, and astrological sign. These four variables are independent variables, and the obesity, it is your the y variable or the dependent variable. Okay, now it may so happen that just like linear regression, logistic regression can work with continuous data and discrete data. Okay, for example, the weight and age, these two are continuous data, and genotype and astrological sign, they are discrete data. Okay, so okay, and so suppose I have told you earlier that suppose your p value, you have found that the after performing the test, you can find out the p value, and if you find that some variable, if you find that p value is greater than 0.05, you can neglect it. Okay, or if you also want to do that before the performance of the regression test, there is also another method that is called Wald's test. This is not required actually. So this is a very basic things. This is not required because even after finding all this those values or the coefficients, you can also find out the p values. There is no problem. Okay. So what is done in a nutshell actually? So you use, in case of logistic regression, there is a sigmoid function. Okay, and what happens that this y-axis in logistic regression, it is actually transformed from the probability of obesity. This is definitely representing the probability of obesity. It is transformed to the log odds of obesity. So just like the y-axis in linear regression, it can go from minus infinity to plus infinity. Okay. Now you can ask that what is means by odds of obesity. The odds are the ratio of something happening divided by to something not happening. Okay, it means the probability that mice are obese, it means that the probability that the mice are not obese. P in this case is the probability of a mouse being obese and corresponds to a value of on the old y-axis between 0 and y. So we can take, if we take the log odds of obesity means, so if the probability that the mice are obese, it is p, then the mice are not obese, the probability will be 1 minus p. So if you take the log value, so it will be log p divided by 1 minus p. Okay, so you can transform this probability of obesity to log odds of obesity, log p divided by 1 minus p. You can transform it, and later on you can see that after this transformation, okay, so you will convert all these values and you will plot these values here again. Okay, you will plot these values here, and your values will lie in plus infinity to minus infinity, and then again you actually you cannot take the residuals from minus infinity to this line. You cannot take these things, so you basically transform this from using this particular formula. You transform these lines from here to again here. Okay, in this line you can transform it using this formula. You can transform all those values, and after transforming you can you can find out all these values. If you multiply those values, you can find out all the likelihood for all these particular curve. Okay, you can find out. And similarly, instead of this curve, if you shift the curve here, then again in this way you can find out the likelihood for all these curves. Then again you can for another sigmoid function you can find out the likelihood for all those data points. And using this method repeatedly, the particular in which particular sigmoid function will provide you the maximum likelihood that you actually use. Okay, so this is basically the mechanism. I'm not going into that much details about the mechanism, and you don't need to know about this mechanism actually. If you just put all these values, it will be automatically what will be the maximum likelihood function. Okay, that will be you just need to select that you need to provide, you will be using the maximum likelihood function that you will be using for logistic transformation. You just need to select that. If you select that, the equation or the relationship that you have shown in case of normally regression equation, the same kind of thing or the same kind of equation will be also provided by the software. Okay, so you don't need to worry about that. Okay, so this is so now we are ending the part of regression thing. Okay, so in the next class we will be starting to discuss about the structural equation modeling, and it is actually better if we discuss principal component analysis earlier, but I will first start factor analysis, that I will start earlier. The factor analysis I will start. Okay, exploratory factor analysis I will start in the next class. Then I will discuss the confirmatory factor analysis when we will discuss the structural equation modeling. And during that time, I will also discuss the PC or principal component analysis. Okay. So now